Recording is on.
Good to know.
Okay.
Aziz, will you do an introduction or what's the plan?
Yes.
Okay.
Just a second.
No rush. Just wanted to ask, sorry.
I'm working alone, you
Yeah.
know.
Yeah. We have enough time. It's Saturday, you know. There are no meetings or anything else.
Okay, guys, we can start if you're ready.
Yeah,
Yeah.
we're ready.
Okay, guys. So, welcome everyone. It's been a long time, so we didn't have a meeting. So today it's really interesting topic. We're gonna talk about loop engineering, and like always, we have great guests. We have today Rainer and Murat. So I think we're gonna learn from the best in the industry. So without further ado, guys, you can start
Thank you.
whenever you want. Yep.
All right. Then maybe I'll try to again to share the screen and
Yeah.
if
It's
if that works,
it's in
then we are
your.
fully ready.
It's not Google Meet. Yeah.
Yeah.
Okay.
Do you see something?
Yes.
Yes. Good. It's there. All right. Well, then I would say we can already start. So hello and also welcome from our side. Thanks for the introduction, Aziz. And we would start with the general introduction of the both of us.
So, hello everybody. I'm Murat Sari, and with my partner Rainer Hanekamp, we created the company Sovarius AI. We are doing AI engineering. That means all about local models, AI agents, and agentic UI. So in recent weeks, we get promoted to the maintainers of Copilot Kit Angular part. So there are also some great blog articles out in our blog about this. You can read it and try it. We're doing open source development, training and workshops in that area, and as well consulting and implementation work if needed. For myself, I'm over 20 years in the business, so I have created several companies. I'm doing computer vision long ago. I started with that. It's part of my DNA, and since LLMs are based on that, we have a pretty good head start in that area as well. We are doing Angular trainings together with Rainer since several years. So workshops, public workshops, private workshops in bigger companies. So we have a lot of experience in that area. Rainer, to you.
Thank you. Thank you. Yeah, my name is Rainer. Actually, Murat and myself, we are both coming from Austria. Same that applies to Murat, although I don't have this theoretical background in terms of 3D engines and that stuff. I am a software developer. I spent a lot of time with Angular. Before that, I was doing a lot of Java and .NET. I'm also a good Google developer expert for Angular. And there's Murat, also part of Soverius AI. What we want to do in this talk is, first of all, it also has the title Loop Engineering with Local LLMs. So the first part will be about, really, if you say you want to have a model that you want to load on your local machine and you want to use it for software development, for writing Angular applications, how does that look like? What is necessary? And I will do a quick demo, and then Murat will say a little bit about the theory, could be a little bit of deep dive. And based on that, we are then also going to loop engineering, explain the concept behind it, and also have prepared a little demo so that you can understand what this is actually all about. Before we start, you don't need local LLMs for loop engineering, but it just fits. So if you say no, you have an existing subscription with GPT, or you're using Claude Code, that's not really a problem. It will also work. And in our talk, we are going to use Codex for it, but it also works with Claude Code, Anti-Gravity, Cursor, or whatever you are using. So as I said, we will start with a quick demo on what it means if I would not say, I want to start a local model on my machine and I want to use it for software development. So I have already prepared a few things. Let me clear the console. So usually you need to download an application, which is called the Llama server. That's the one of the most often used ones. And yeah, let's use that. And as you see here, you are saying you want to run it on port 8088. And what Llama then wants to have from you is that you need to give it the path, or at least the name of the model that you want to use. And it is important that this is an open weight model, so it needs to be possible to be downloaded. It also needs to come in a proper size so that it also fits into your memory. In my case, we are using here Gamma 4. That is not a Chinese model, as most of the open weights are. That's a model from Google. Comes with 26 billion parameters. It's not so important, but let's just give it a start. Wonderful. This was what I was expecting. Let me quickly go back, Llama server, and give it a try again. Now it looks better. Always the demo gods, or however you want to call it. And now we're already ready. So it's only this simple command where you tell it the model, this is the model that I want to use. It will consume it, will start up a server for you. And everything that you need now is that you can point already to localhost 8088, and you will then hopefully see a chat. So this is it, as we know it from ChatGPT, and I could now say hello, like this. It says, yeah, I'm using the uncloth, the Gamma 4 model, and you already see here the answer. It says, hello, how can I help you today? And if you're unsure if it's really the model, then you see already in the console, it is the one that is producing here these tokens. So I'm going to say here, I'm good, how are you? It will hopefully answer again with another message. So we see the model is working, but as I said, we also want to use it for software development. That's why we're actually using it to write an Angular application. So let me start Codex locally. This is the normal Codex CLI. It might come as a surprise for some of you that Codex, but also Claude Code, that these agents allow you to use also local models, which means these companies will not earn any money because you're not using their models. But you can do that. I didn't believe it the first time when I heard it. So in this case, Codex starts up. It gives me the confirmation that it is now also using the Gamma 4 model. It has been configured for that. And now I can start to do the same conversation as I could before with the normal UI window. So we see it now, it is working with the hello. That usually takes a little bit longer, because what you have to realize is that these coding agents, they come with a lot of initial context. So they're loading a lot of skills into it for obvious reasons. The English skills are also running here, the MCP tools and everything which they have. So that means it doesn't start empty in that sense, but it loads already a lot of tokens into it. So we see it's working. I guess if we do here a live video recording, it doesn't really make it faster in that sense, but at least we should get a proper answer. So what you usually need to do, and Murat will then discuss this a little bit in detail, of course, you need to provision the proper hardware. But in the end, the first startup with Codex and also Claude Code takes a little bit longer. And the following, the sequential messages which come afterwards are usually much, much faster answered. Yeah, so for some reason, I think stop processing has already been done. Yeah, here we have already the answer. So it says, hello, I'm ready to help you with whatever repository we are currently in. And I say, I have no idea, or whatever. It asks me what it should do. And then hopefully it doesn't come to any bad ideas and starts to dive into the code or whatever. Yeah, so let's see until we get the answer. Takes longer as expected. No problem. It can be a lot of time to take it at once. And now you see it has already started, or it's starting now to take a look at the code and starts to give me suggestions on what we could do. So like any other normal agent would do. But again, this all happens now locally on my machine. I am using here, as I said before, Gamma 4 model with 2060 billion. And now the question is, what does this mean? Or what does this mean in general if you want to do here the same thing? And that's now the point where Murat steps in and shares his screen probably.
Yeah, let me try if it's possible. So looks entire screen. So I'm clicking share.
Yes, it works.
It yes. Works perfect. Yes. So as Rainer mentioned already, we need to think about provisioning the hardware. Why? Because maybe this step is very important for loop engineering. The idea of Rainer's talk is that we have somewhere a machine, an agent which controls maybe a full machine, and for that we need hardware when we use a local LLM, even then. And of course, here's the image about the architecture, the memory architecture of an Apple Silicon. And so why I choose Apple, because Apple is the greatest product for hardware, but it's really expensive. But it also shows you how the architecture direction is going in the future. Because the unified memory architecture is something Apple did not start with the Apple Silicon. It already started with the first iPhone. Because as Rainer mentioned, I worked in the 3D area. I created 3D rendering engines. I worked on games. And with the iPhone, we had the first time a unified memory. That means we could upload data to the memory from the CPU, and the GPU could access that. So now, if you are not that familiar with that hardware, what does it mean? In an ordinary PC, so if you're a Windows user, you usually bought a motherboard and CPU, you bought some system memory, and then you have some dedicated hardware, a GPU. And when you want to transfer data from the hard disk to the GPU, first you need to copy it into system memory, and then from the system memory, you need to copy it to the video memory, the so-called VRAM. Why I'm explaining you that with memories, why at all is this needed to understand? When we're talking about open weight models, that means like Rainer showed us the Gamma 4 model, or if you have a little bit more beefier machine, it could be also some DeepSeek V4 Pro Flash, whatever version of it. Then, of course, it matters because these open weight models come in a special file format which has all the weights inside. That means these trained parameters, and these trained parameters need to be on the GPU memory. Yeah, you should not execute it on the CPU. So this is the first question: why? Why we cannot just use our big system memory and our CPU to execute them? The issue is when you look at Rainer's model, for example, it has 26 billion parameters. And usually we are talking about matrix multiplications. I don't want to bore you with that, but in the end is matrix multiplications where the matrix is a big tensor of 2.4 million floating point numbers. And if you do that on the CPU, it is just that slow. Yeah. The GPU is basically made for fast parallel processing. So if you're a gamer, yeah, you know frames per second, how fast is the game? You know when you load a model into your machine, it has thousands or millions of so-called vertices. And in the end, they are also doing matrix multiplications. So in the last 2 decades, the GPU was optimized more, and now we have dedicated tensor cores, for example, which are really optimized for that kind of AI work. Yeah. So in a nutshell, you need to get this weight data, Gamma 4, from the disk into the video memory, and the video memory is executing as fast as they can.
Murat, can I quickly show where I actually have that model? Because I just say this is the model and it was just there.
For sure.
Yes, just a quick, then we can also see the size that it actually occupies.
Can you?
Which is also interesting.
Can you share through it? Okay.
If you stop your sharing, then I can share, and then I will hand it back to you quickly.
Yeah.
So
sure.
let me quickly.
I think I stopped the sharing.
All good. Yeah. So I hope my screen is shown somewhere now.
Yeah, I see it.
So this is the place where Llama was downloading it automatically. So I said to you already before, I'm just providing here the name of the model. And it was actually that. So if you remember, it was Unsloth. This is kind of the provider, in this case of Gamma 4. And what is important here?
There is an user, he says he cannot see the screen share.
I should be.
I can see it,
Okay.
but maybe Mohammed.
You can see it too. I can see it too. The screen.
Okay.
Yeah, I think it's resolved. Okay.
Okay. Good. So that's the model. Llama server, this application that I was using, is downloading it automatically if it's not there. In my case, it had it already in the cache.
No, it's
and the interesting.
Okay.
Pardon?
Yeah, it's okay. No, it works.
Okay.
Yeah.
Good.
There is delay.
Okay.
You are lame, Rainer. I understood.
Yeah. And the interesting part here is this, because the model in this case occupies 14 gigabytes. And now the question is, what kind of machines do I need to use? What do I have to be aware of? And what does this 4-bit here actually mean?
Maybe leave that screen. But anyway, yeah. So that was okay. Maybe can you reshare your screen card?
Yeah,
again?
Of course.
Maybe I can explain a little bit there in the model card.
Yeah, because that is important for everyone.
Yeah.
This is I need to understand why I'm taking this or what is necessary.
Yeah, when we look at the model name, for example, Rainer, maybe you can make a red highlight about Gamma 4, 26 billion. Okay, so
the whole name, yes.
Yeah, the whole name. So first we need somehow to read the name. And in that case, we see Gamma 4. This is the model name. This is from Google. And it